This tape has been produced by Watts Regulator to instruct certified contractors in the troubleshooting and repair of the Watts 909, 009, 990, and 992 series valves. The contractor should already be familiar with the RPZ testing procedures as outlined by AWWA, ASSE, USC, or other procedures as required by local jurisdictional authorities. For our tape, test results are illustrated with the Watts TKDR and TKDP digital testing instruments and the TK9A analog tester. The 4-inch 909 reduced pressure zone RPZ valve, shown here mounted in line with arrow facing the direction of flow, also comes in sizes from 3/4 inch to 10 inch in diameter. Like all Watts valves, no special tools are required in a standard 909 repair procedure. Watts recommends that you obtain a copy of our repair and maintenance literature from any one of 45 local agents in the U.S. and Canada, or from our worldwide chain of distributors. Watts supports those distributors with a network of master parts suppliers to ensure prompt local delivery. You should use only authentic Watts repair parts to ensure proper operation and longevity. Note: the use of imitation parts will void the Watts warranty and all approvals. Only FDA-approved lubricant can be used, and only where instructed. The 909 consists of 2 independent spring-loaded check valves with a pressure differential relief valve located between the 2 checks. The relief valve incorporates a hydraulically controlled diaphragm with the high-pressure side connected to the supply side of the first check by a high-pressure sensing hose. The relief valve is designed to maintain a lower pressure in the reduced pressure zone between the 2 checks. If the pressure in the reduced pressure zone increases due to a fouled check, the relief valve opens, discharging to atmosphere, which maintains the required pressure differential sensed by the relief valve diaphragm. If there is a constant reading of 6.8 to 7, the valve is functioning normally. If there is a low or fluctuating reading and the relief valve is dumping water, then the first check assembly or relief valve must be inspected and repaired. If you shut off the downstream side and the water dumping stops, then it is probably the second check that is fouled. Close the upstream and downstream isolation valves. Open the air bleeds to relieve the pressure. Remove the cover plate by backing off the 6 bolts holding it in place. Caution: the cover plate is under a spring load. 2 opposite bolts should be kept in place so that a minor tension can be observed. As the cover bolts are further loosened, the cover should be loose, showing no spring load. You can check this by pressing down on the cover with your hands. Remove the cover and the cover O-ring. Next, slide the first check spring assembly straight out, being careful not to hit the assembly on the inside of the casting. This could cause damage to either the assembly or the fused epoxy coating. Observe the rubber disc. An even circular seat impression on the rubber disc is normal, but it should be checked for debris or nicks in the rubber which could have caused the check to leak. For maintenance of the rubber disc in the 909, take an adjustable wrench and turn counterclockwise to remove the lock nut holding in the large washer. The disc can be flipped over and used again, as long as there are no holes or tears and the rubber appears smooth and pliable. If there is a cut or tear, replace the disc. Do not lubricate. Place the stainless steel washer beveled side down to avoid damage to the disc. The stainless steel washer sits on the shoulder of the spring assembly, which prevents the stainless steel lock nut from being over-tightened. The spring assembly is held in by 2 C-clips on each side of the disc assembly, as well as one more C-clip at the bottom of the assembly. The spring assembly usually lasts for the life of the valve and under normal operating conditions should not need replacement. The seat ring is held in place by wire retaining clips. The seat ring face should be checked closely for nicks or debris. A pair of pliers is all that is needed to remove these clips. One clip removes counterclockwise and the other clockwise. The seat is then free and can be pulled straight out. The O-ring should be checked for nicks or deterioration. Also observe and feel the fused epoxy coating and O-ring groove for any imperfections or irregularities. With the first check removed, inspect the reinforced high-pressure sensing hose for debris by unscrewing and backing out the adapter. Note: the extension tube on the adapter prevents rust buildup from clogging the adapter. Clean and reassemble. If the hose was clogged, it could prevent the relief valve from opening during a normal test. Reassemble the first check seat by putting the seat and lubricated O-ring and seat back in place and reinstalling the wire retaining clips by hand into the groove in the valve seat. Note: instead of wire clips, the 2.5-inch and 3-inch 909 seat is held in by protruding tabs that fit into the groove of the valve casting. The seat is released by rotating it 90 degrees counterclockwise and lifting it straight out. The check assembly with a captured spring is the same type as the 4-inch to 10-inch sizes. Caution: the spring subassembly is under enormous pressure and is best serviced by the factory. If field rebuilt, it can only be serviced in a press designed for spring compression using caution. To reassemble, simply slip the check assembly stem into the hole in the middle of the seat and slide it into place. Next, lubricate and replace the O-ring and the valve cover. The bolts should be tightened by hand and then with a wrench in a crisscross pattern. Slowly open the isolation valves, number 1 first, then number 2. Bleed the air off and retest. If the first check was okay and water continues to discharge, the relief valve must be inspected. Close the isolation valves and drain the valve. There are 8 bolts easily removed with a box or socket wrench, and the cover can then be lifted off. The high-pressure sensing line fits into the mating hole in the relief valve cover. The rubber diaphragm should be inspected for cuts or cracking. To examine the seat and rubber seat disc, the disc assembly plate has to be lifted firmly upward to counter the tight fit caused by the wiping bore and O-ring that seals the unit. Check to see that the O-ring is in its proper position. In a high back pressure or water hammer condition, it could become dislocated, causing leakage. Once it is removed, the rubber disc is inspected for signs of fouling or indentations in the rubber. The top of the assembly plate is removed by unscrewing it in a counterclockwise direction. The entire seat disc is replaceable and is unscrewed in the same manner. The rubber disc is bonded to the brass holder to prevent the disc from slipping. The small O-ring, as well as the shaft O-ring and wiper seal, should be replaced at this time. A small amount of FDA grease is used to lubricate the O-ring and wiper seal before reassembling. The stainless steel seat should be checked for any imperfections. If it must be replaced, it can be removed by tapping counterclockwise with a hammer and a blunt screwdriver. It can then be unscrewed by hand. The O-ring seal should also be checked at this time. Replace, gently tapping into place. Care should be taken not to mar the seating surface. To inspect the lower portion of the relief valve, locate the large nut near the air gap drain. The large nut is the bottom plug assembly containing the preloaded or captured vent spring. It can be loosened with a standard pipe wrench and then removed by hand. There is a stainless steel sleeve inside the bore that should be checked by feeling for irregularities with your fingers. The O-ring on the bottom plug assembly should be lubricated with grease, then tightened into place with a pipe wrench. The relief valve assembly is held straight up and carefully brought into place with the lubricated O-ring fitting tightly into the bore. The spring load should be checked by pushing down on the top of the relief valve assembly. This also ensures the guides are seated properly. The diaphragm is placed on the cover with the high pressure notch lined up with the hole at the top of the cover. The diaphragm and cover assembly are mated with the valve body using the high pressure sensing hose as a guide. Push down on the cover as you hand tighten the bolts. Then finish tightening in a crisscross pattern with a standard wrench. Repressurize the valve and test. The relief valve opening should read 2.0 or greater. The 990 series is similar in operation to the 909, except that the relief valve does not feature the high-capacity air-in, water-out design of the 909s. The 990 and 992 offer a bottom-mounted relief valve for installation and service flexibility. In the high-pressure sensing line, there is a pitot tube that reads pressure from the flow of water. The notch on the adapter indicates the direction of flow and must be pointing upstream. The 990 and 992 series feature a captured spring in a center stem guided assembly. The spring assembly must be removed to clean the seat disc. As with any spring-loaded mechanism, keep fingers away from pinch points. The spring assembly has a heavy preload and it is not necessary to disassemble the spring module. Remove the access cover. Apply leverage between the spring guide assembly and the disc assembly. Compress the spring guide assembly slightly so it will pop free from the notches on the back of the disc assembly. Completely remove the spring guide assembly by unhooking the other end from the mounting bracket. When replacing the springs, make sure the heavier double spring goes into the first check. Unfasten the two bolts on the side of the body opposite the access cover. Reach in through the access opening and remove the entire clapper assembly. Watts uses one of two methods of retention. Method A. Use an Allen wrench to remove the set screw which secures the stainless steel spacer to the retainer pin on the clapper assembly. Or Method B. Gently tap retainer pin prior to sliding out of the plastic spacer. The seat device removal jig consists of an L bracket which is bolted into the bottom of the valve. A threaded rod and propeller-shaped jig with a lock washer hold the assembly together. As the threaded rod is screwed outward, the jig is pulled forward, pulling the seat out of the valve. To install a new seat, a rubber-faced disc replaces the removal jig. The rod is tightened, pushing the replacement seat into the valve. The relief valve is mounted under the 990 and 992 with high-pressure sensing line connected to the supply side of the first check. After the high-pressure line is removed, the 6 cover bolts are removed with a standard socket wrench. Next, the diaphragm and spring assembly are pulled straight out, being careful not to hit it on the casting. The outer seat is checked for flaws, as well as the inner casting. As always, the diaphragm and rubber seat are checked for cuts and/or cracking. The mating bronze casting on the inside of the cover is also checked at this time for any imperfections. The bronze bypass sensing line is attached to the body by a screw. Remove the screw on the sensing line and the 6 cover bolts so that the cover and sensing line may be removed. The sensing line and its O-ring can be checked visually for signs of wear. Check the cover O-ring and the seal on top of the cover, which mates with the relief valve piston, for any signs of damage. The relief valve piston mechanism lifts straight out. Check the rubber disc. An adjustable wrench is all that is needed to replace the rubber disc if necessary. Remove relief valve spring. The check assemblies are held in by a retainer separating check 1 and 2. Pop out the stainless steel seat and visually check the surfaces for fouling or irregularities. Note: the inlet or first check assembly must be taken out first. This is done by simply loosening with a screwdriver and lifting it up and out of the valve casting. The second check assembly is removed in a similar manner. The second check assembly has an extra groove in the seat to help facilitate removal from the valve casting. The check assemblies are disassembled by unlocking the spring cages. This is done by pressing them down and twisting them 1/8 of a turn counterclockwise. Check the seating surface and O-ring for imperfections. Feel the inside surfaces with your fingers, making sure the surfaces are smooth and free of imperfections. Caution should be taken not to switch springs from these checks upon disassembling. The first check has the heavier spring. When reassembling the valve, make sure the second check is put back first. It must be pushed all the way into the valve casting. Next, the first check is pushed in place. The O-ring on the relief valve seat should be inspected and replaced or lubricated as needed. Replace the seat by simply pressing it into place with your finger. Drop the relief valve spring into position. The stainless steel retainer is then slid into place. Note: if the retainer will not slide down, be sure that the check modules are pushed all the way in. The relief stem assembly fits into the hole in the cover. The bottom of the piston will center itself in the relief valve seat. Before tightening the cover, the sensing line is pressed into the cover and onto the body of the valve. The bolts and screw are then replaced. Restore the valve to operation and retest. Watts has produced this video to cover the basic service procedures on large diameter products. If you encounter situations beyond these outlined here, please call your local factory-trained Watts agent for assistance in troubleshooting the valve and system. As always, Watts will provide you with knowledgeable assistance, the latest in literature, training, maintenance videos, and of course, the finest products in the industry. Look to the leader. Look to Watts Regulator.